Hello, everyone. My name is Xiong Lin. I'm a machine learning engineer from LinkedIn. Today, I'm going to present our work of scale graph construction from semantic understanding. So today, I'm going to first talk about the motivation, then the data preparation, then our training pipeline, and in the end, I will discuss the result and our future work. So at LinkedIn, currently our scale taxonomy consists of a flat list of 39,000 scales, which does not connect with each other. And so what we want to do is apply our work. We want to convert this flat list into a dynamic graph of connected scales. So for this, at a glance, on the left side, you see we have a scale taxonomy, which is the 39,000 scales, and we want to use our scale graph construction from semantic understanding work to convert it to connect them into a hierarchy relationship, especially the parents-children relationship graph. For our input data and the feature, we start from a seed graph, which created by our taxonomists. And we use the ages in the scale graph, and we also use the age attributes such as scale type. Then for each node of this seed graph, we also leverage the scale attributes such as scale type, scale domain. The most important thing for feature are the contextual feature between the scale pairs, which is the contextual sentences containing the scale pairs. So there's multiple sources we have tried, including LinkedIn's job posting sentences, the Wikipedia scale descriptions, and in the last we found out to synthetically generate training sentences have the best performance. So next is our training label generation. So we have a positive label directly from the scale graph ages. From there, we are going to generate some negative labels using some the following 4 rules. Instead of randomly sample a pair of scales within our scale taxonomy. So the first type is cross-industry pairs, such as on the right side, you see the engineering and the finance, they are from different industries. So this is form of one negative labels. And the second is the sibling pairs. For example, in the PyTorch and the TensorFlow, they are the siblings of the machine learning. So those two are negative labels. And we also have niece nephew pairs such as TensorFlow with the cognitive computing, and also we have third plus generation such as engineering and PyTorch. These pairs are also negative labels. So once we have the positive and negative labels, we can next is to generate some contextual sentences. So here, what we do is we concatenate the scale canonic name and the scale descriptions, and then separate them by the spatial token of ACP, and add the CLS token in front of each sentences. So for one pair of scales, we can generate 4 training sentences. So next, I will talk about our training pipeline. So our training pipeline consists of 5 modules. So we start from a seed graph, and you see on the bottom right, and then we generate some negative labels. Then we synthetically generate some training sentences. Then we fit those training sentences into our pre-trained BERT model and finding its weights, and we take the sentence level embeddings to fit into our relationship classification module to predict the relationship between the 2 scales. So here is our results. So we have first we do the offline evaluation on the 20% of holdout test set. We achieve a good performance on the both precision and recall, which is 86% of. The second offline set is randomly sampled test set, which we measure the confirmation rate, which is the accuracy of the positive predictions, and we can achieve 76% accuracy. The next one is we are currently working on the online A/B test, which we have seen some initial results to lift up some of our business metrics. So for the future work, we are going to plan to leverage the generative AI, such as ChatGPT, to generate more meaningful contextual training sentences to help improve our model performance. The second is we want to build a framework to construct the heterogeneous taxonomy graphs to connect the skills to other types of taxonomy, such as title, industry, and company. This concludes my presentation. Thank you very much for listening. And if you have any questions, please feel free to reach out to us. Thank you.